Here we have the digestive system, part 10, continued on page 876. We're still looking at the microscopic anatomy here, as well as the gross anatomy of the small intestine, and I'm just reviewing this one portion right here where we were looking at the villi, and I just wrote in here crypts of Lieberkühn. It's important to note that deep here inside the invagination between the villi are the crypts of Lieberkühn. Note the umlaut. So there's also these little cells here that are referred to as enteroendocrine cells, which means the endocrine cells of the enteric system or the digestive system. CCK and secretin are being released here. So these will become important items when we look at the pancreas. Because they actually cause the pancreas to become functional. CCK is going to open up the sphincter of Oddi, so that's an important detail. We get enzymes from the pancreas through the sphincter of Oddi. We get also bile through that same sphincter. So, and when does that sphincter open? It opens especially when we see fatty chyme, salty chyme, a chyme that's hypertonic in salt content, but also in acidity. Why do we associate that with protein? Is because that's where the acidity comes from. It takes longer to metabolize protein, and more hydrochloric acid is secreted, so that means more CCK, secretin, etc. Okay, that's the next page. Then we get to our liver. Here's the big gross anatomy overview. This liver, now this is the very top of the liver, and this would be up against the diaphragm here, the very top. This right here is the right lobe on this side. This is the left lobe. This looks like a pretty hefty liver. Maybe a few trips to the bar, it's hard to know. But at any rate, we also have, just peeking through there, because this is a top view, not a front view or anything, we have our gallbladder right there. There's also this interesting feature right here that we should note. This is the round ligament, and or ligamentum teres. Teres means that round. And so this used to be the umbilical vein. The vein is what comes back to the baby's heart from the placenta, which is carrying mom's nutrients and her oxygen. Okay, and so here we have the liver again. This time it's flipped over, and now this is the right lobe. We're looking at it from underneath. This is the left lobe. This is the caudate or posterior lobe, and that this is the quadrate or little square lobe. So quadrate over here is the left lobe, and then over here is can you read that? There it is. Caudate lobe of the liver, and that's in the way back here. And then we have our right lobe is this big thing right here, and then we have gallbladder peeking out right about here. So what's the gallbladder doing? It's taking up the slack, and the times when the sphincter of Oddi is not open and we are secreting lots of bile, it has to go someplace. So it goes retrograde backwards up into the gallbladder and is stored in the gallbladder. Okay, now first of all, we have this big overview here now, and but in order to make sense of this, I need to show you what happens when we take a look at the liver. Now this is not a human liver. I'm sorry to say. It would be interesting if we had livers that were this rugged. We would be really rugged little animals ourselves, but we're not. We're actually very fragile little animals. And so we look at livers this way because only certain animals are organized well in their livers. And I'm going to bring a lot to the program. I'm going to talk for a while about this. So notice that there is a very clear, it looks almost, like a little honeycomb or something, six-sided. These are all cells that are arranged in how shall I say, little plates, and in between the plates there's going to be space for blood to flow down through the plate. So these are sinusoids. And where's the blood coming from? It's coming from the stomach, the large intestine, the small intestine, from the spleen, and so that means that the liver is getting the first look at all nutrients. Now, what animal have we chosen here to use? This is a pig liver. Pigs are happy, healthy, very functional little animals that can bounce off of things and keep on ticking and everything, and so they don't take anything personally. You can call them a pig and they're fine with that, right? So I just need you to know that these are hardy animals and we are fragile animals. We worry about stuff or get angry, have any kind of an emotion, and we have our injury to the liver. Remember the liver's responsibility from back at the endocrine system. The liver makes most of the growth factors that become resident. It's not the pituitary growth factor that makes the skeleton and those big muscles, right, on the athletes that we see. It's not. It's the liver. So think about that for a few seconds. You want big muscles? That means you need to have a fabulous liver. So think about it. Think about that six-pack before going to bed. Oh my God. Or, you know, whatever other entertainment you do that the liver is going to have to fix at night while you sleep, right? So if you want to have a fabulous body and look buff and beautiful and all that sort of stuff, you better have a fit liver. Okay, just saying. Here's a little close-up. Here's these beautiful six-sided trabecula that enclose the space on the pig liver. Notice that we have these little passageways that flow to a central vein right there. Here's the big overview right here, and it's going to take me a little extra time to talk about this, but we have our little plates here of cells that conduct the flow of blood. Notice that we're getting blood from both the arteries as well as the veins, and we have something here called a triad, a portal triad. It has a branch of a bile duct, a branch of a portal vein, a venule, and a branch of the hepatic, not the portal, the hepatic artery, and now it's an arteriole. And so there's three things here, count them, 1, 2, 3. And the way that the bile is getting into the bile duct, it's going this way, right? So there's little tiny bile canaliculi, actually, that are heading back in this direction and filling up the bile ducts, and the cells are making the bile, whereas the arteriole and the venule are sending blood this way to the central vein. Eventually the central veins all meet up with each other, and they come along this way, and eventually they're going to go all the way back. They're collected and go to the hepatic vein and back to the inferior vena cava, and then back to the heart. Okay, so that's the program here. And I want to emphasize that our liver has to fix everything at night while we sleep. And so anything that we do by day to cause stress to the liver, how would we cause stress to the liver? We would feel that would be, for instance, getting an infection, getting hit by a car, getting anything that actually limits, any bad stress that limits the growth hormone capabilities at night. Remember that cortisol is guiding growth hormone. It's like the little bloodhound that's guiding growth hormone from the pituitary as well as from the liver to go here, 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 here. Let's fix this, let's fix this. And if there's a major injury or an infection, then the growth hormones and factors do not get to their correct location. So I'm keeping this visual here to let you know a human does not have trabecula like this. You can't see anything like that. It looks, and they're very translucent. This whole system in the human is very, it looks like Waterford crystal ware. You know, it's just delicate. We are delicate when it comes to emotions, so we have to be very careful and that sort of thing. Okay, I'll pick it up again in the next episode.